Hello and welcome back to my channel. In this tutorial, I'm going to talk about how to implement linear regression with R language. Linear regression is a widely used statistical technique for modeling the relationship between a dependent variable and one or more independent variables. In this tutorial, we'll briefly learn how to perform linear regression in R using the lm function and evaluate the model's performance. This tutorial covers introduction to linear regression, data preparing, fitting the model, accuracy check, and finally source code listing. Linear regression models the relationship between a dependent variable target and one or more independent variables which are predictors by fitting a linear equation to the observed data. In simple linear regression, there is only one independent variable, while in multiple linear regression, there are multiple independent variables. The linear equation can be expressed as y equals mx plus b, where y is the dependent variable, x is independent variable, m is the slope of the line, b is the y-intercept. The parameters m and b are estimated from the data using various techniques such as methods of least squares. Once the parameters are estimated, the linear equation can be used to predict the value of the dependent variable y for new values of the independent variable x. Next, we'll start by loading the required libraries for this tutorial. Here we use Caret library. In this tutorial, we'll utilize the Boston housing price dataset for regression analysis. We'll begin by preparing the data, which involves splitting it into training and testing sets. Additionally, you can examine the structure of the dataset using str command. In this dataset, med represents the target variable output or label, while the remaining variables serves input features. Here we load the Boston dataset and we'll print the data frame with str command. Here is str, the function, and it displays the structure of an R object. Here we have, this is a data frame type, and it has 506 observation data and 14 variables. This is the name of the variables, which is column names, and the type and some portion of the data. Then we set a seed here and split data into training and the testing sets. Here we use 85% as a training set. Then here we separate train and the test parts. In the model fitting part, we are using the lm function in R to fit a linear regression model. In the code below, the lm function is utilized for linear regression modeling. So here we use lm function. The formula MED specifies the linear regression model. In this formula, MED represents the dependent variable, also known as a response or target variable, and the dot denotes all other variables in the dataset, excluding MED. This notation instructs R to utilize all other variables in the training dataset as predictors to forecast MED. The argument data equals train specifies the dataset from which the variables are derived. In the context, trains refers to the training dataset containing both the dependent variable and the independent variables usually utilized for prediction. After fitting, we can print the model summary. Here we use a summary function, and this function gives the model summary. So here is the information about the model. It shows all coefficients of the columns, and then residual standard errors, R squared, and F statistics, and p-value. Next, we'll predict test data with a trained model. Here we use all columns of the test data except the 14th column, which corresponds to the med variable. This ensures that the predictor variables in the test dataset align with the predictors used in the model fitting process. After prediction, we assess the prediction accuracy using the several metrics, including mean squared error, mean absolute error, root mean squared error, and R squared. We'll examine these metrics to evaluate the performance of our linear regression model. Here we calculate the evaluation metrics, the MCE and MAE, and from MCE we'll get the RMCE, and from a summary object we can get R squared. Summary is here, so we get the model summary and it provides R squared value. Then we print evaluation metrics here, and the result looks as shown here. Then we'll create a plot to visually inspect the results to our linear regression model. Here we use actual and predicted values. Here is the test method is actual data, and this is predicted data. Here is the result. This plot allows us for a quick visual comparison between the actual and predicted values, and helps us to assess the performance of a linear regression model. The red dots are actual data, and this blue line is a predicted one. That's it for this tutorial. In this tutorial we learned how to perform linear regression in R using lm function. We split the data into training and testing sets, trained the model, evaluated the performance using evaluation metrics, and visualized the results. Linear regression is a powerful tool for modeling the relationship between variables and making predictions based on observed data. And here is the source code. I'll put the link to source code in description. If you like this video, please consider subscribing my channel and hit like button. Thank you for watching, and see you next time.